All right, my name is Roger Weitzel. It is December 11th, 2020, and hope you guys are doing well. I hope you're surviving okay with this COVID thing, and it sure is different. And we do online learning now and online teaching. So let's have some fun. Today we're going to talk about sine and cosine, and let's get into it. I'm going to share my screen, and I started drawing a triangle here. So let me finish that. So the key on this one, or one of the keys, is that we're dealing with a 90-degree angle, which means this is a right triangle. And the way I've drawn this, that is a 90-degree angle. So when I have a right triangle, I can do some relationships between the sides. So right off the bat, I can say, I'm going to talk about this angle. And part of what we're going to discuss today is it's really important that you specify which angle you're talking about. So let's, for instance, say that we're talking about this angle, and we're going to call that theta. So if I'm talking about this angle, this is going to be the opposite side. The one that's across from the angle is the opposite side. The one that's next to the angle is adjacent. So I always like to start out with here's my angle. The one across is the opposite. The one next to it is the adjacent. And the one that's across from the 90-degree angle is always going to be your hypotenuse. Now, there's a relationship between these sides. Now, we are going to talk about sine and cosine today. So we are going to say, well, I'm going to just talk about this little phrase that everybody seems to use, so, ka, to, a. And it's an Indian name for trigonometry. Really, it's just a quick and easy way to remember the relationships between the sides. I will sometimes have students ask, how do you spell SOHCAHTOA again? Well, just to clarify what we're doing here, the S stands for sine, and that's going to be opposite over hypotenuse. So that's your sine opposite hypotenuse. Then we're going to have the second function, which is cosine. That's going to be the ratio of the adjacent and the hypotenuse. So that's going to be adjacent over hypotenuse. So the one next to it is adjacent over the hypotenuse. That's your function sine. And then our last one, tangent, is going to be the opposite over adjacent. And again, these are just ratios. So we're going to have values in here in a problem that we're trying to solve. But we just want to get this relationship kind of started in your mind, because this is going to be used a lot. And we are talking about this angle. This problem is going to illustrate that this angle is going to have a different relationship for opposite and adjacent. So in this in this problem, they say we have a right triangle, and we have, it says, let A, B, and C be the angles of the triangle. A and C are complementary, and B is the 90-degree angle. So I am going to just put that in as B, that's the 90-degree angle. Then they're saying that these two are complementary, which makes sense. Complementary means that they add up to 90. And if we have this one being 90, the other two have to add up to 90. So we're just going to make this A and this C. These two are complementary. This one is 90. So they're saying that the measure of the angle is 35 degrees. So let's go ahead and put that in. And just so you can read it, I'm going to put in here 35 degrees, which makes this one what? What's that one going to be? Well, they're complementary, so it's going to be 90 minus 35, which is going to be equal to 45. Sorry, 55. So this angle up here is equal to 55. All right, so we're just putting down all the information that we know. So we know this one is 35 degrees, this one is 55 degrees, this one is 90 degrees. And now they're saying if the sine of A is equal to X, so let's just write that. So we're just going to write sine, and we're talking about sine, and remember we're talking about a particular angle, so we're talking about angle A, and that's equal to X. We have this already set up in relationship to A. So for A, this is the opposite. This is the adjacent. And we know that for this situation, that sine is going to be opposite over adjacent. So for purposes of this, so we can kind of keep track of what we're doing here, we're going to call this line segment right here BC, and this one AC. And so if we're going to write down the ratio for sine of A. So we can say sine of 35 degrees is equal to the opposite is BC. I guess I want to put in large letters. BC divided by, so this is the opposite over the hypotenuse. So that's going to be AC. All right. Now they're saying if the sine of angle A is equal to X, what is the value of cosine of C? So now we would be switching to this angle. So let's just set that up. So now we're talking about cosine, and this time we're talking about angle C. And let's just think about what's happening here. So when we're talking about C, this becomes the opposite. So let's go up here and write in opposite. And this becomes the adjacent. So in this situation, for C, this time they're saying, what are we talking about if the measure of angle A is 35 and the sine of A is X, what is the cosine of C? So for cosine, we're going to want what we have here, adjacent over hypotenuse. So let's type that in. And then let's fill in these values. So for this angle, we've got adjacent, which is BC, divided by the hypotenuse. The hypotenuse did not change because it's always going to be opposite the 90-degree angle. So in this case, we've got AC. So what we notice is that this is exactly what we had here. So the sine of A is equal to this, and the cosine of C is equal to this. In this case, we said that sine of A was equal to X, which means that cosine of C has to be the same thing, which means that this is our answer. So the point of this exercise is that the sine of an angle is equal to the cosine of its complement. So we'll be doing more of these problems, but just want to get you introduced to this. So thank you for playing along. Have a great day, and we'll see you next time.